already, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Graham Middle School. And in this video, we're going to be working on those comparing and ordering notes. And what I want to do before we review how to do some conversions, I just want to make sure you guys are seeing how this works. So in the center of the screen, I have this nice big word. It says equivalent relationships, and what that's saying is that each of these terms are going to be the exact same thing. However, they might just look different. So what I'm going to do is I'm going to give us an example. So normally you do this in Math 6, but we also use the same strategies in Math 8. And so what we're going to do is say if I have the fraction 1/2, I'm able to be given one of these choices or one of these windows, and I'm able to convert between each of them, meaning this: I know that 1/2 is also 0.5. I know that that is also 50%, and if I was to write a picture or draw a picture for that, I could maybe do a circle, and I would fill in half of it because it is 1/2. So make sure you're seeing how these are different representations, but they are all the same thing. Again, that's just bringing home the idea of equivalent. So now on the next part, again it says review of conversions. We will always convert to, let's try that one more time. We will always convert to decimal form. And again, the reason why we do this is that way we have one consistent way to do it, and that way we all have the same idea. So a quick review on conversions. Let's say if you have a fraction and you want to change it to decimal, again, make sure you're dividing the numerator, that's the top, by the denominator. So for example, if you have the value, let's say, if you have the value 3/2, again, you would divide 3/2 to equal 1.5. If you pull up that Desmos calculator, again, you can type it in like this. And so if I say, all right, I take my numerator, so I have 3, hit divide, and it already makes a fraction for you, which is real nice, and you hit 2, and it comes up, again, it says the answer's on the side, so you have it in there for yourself. So now, on the next conversion, we're going mixed numbers to decimal. So what is a mixed number, and how do we convert it to a decimal? Well, very easily, you can do it like this. Again, we're going to write the whole number first, and then we're going to change the part into a decimal. So the way it works is like this. Say if we have the value, let's write 4 and 1/5. Again, it's a mixed number because it has multiple parts to it. So we're going to say, all right, we're going to say, let me get that nice color here for ourselves. We have that this right here, that is the whole. We're saying that is just a whole number, and so we write that first, and then we have the decimal, and then we're going to say the part is going to be the fraction, and so that is the part. So you have to convert just like we did before, and so 1/5 is 0.2, and so you'd write 0.2. So again, make sure you're seeing that whole entire thing is going to be 4.2. A way to do that in your Desmos calculator, if you would like to, you can also do 4, and you would say and, so you would hit plus, and then you would have 1/5. Again, that's multiple ways of doing it. As long as you're able to convert from a mixed number to a decimal, you'll be good. So now moving on, let me go next. So if we have percent to a decimal, again, make sure you understand what a percent is. That means the prefix per means for every, and then cent is 100, so that's how you get for every 100. So all you have to do is take that value and divide it by 100. So whatever value you have, so let's say if you have 780%, all you have to do is take that value and divide it by 100. So we're going to do this value divided by 100. So if you take your Desmos calculator, you're going to say, all right, I have 780, and then divided by 100. So notice how we're switching in between, fraction, decimal, percents very carefully, and we're always getting to a decimal form. So we're going to say, okay, we're going to take and say that is our answer here is 7.8. So we want to make sure you write that this is equal to, let's say, let's put it in back in blue. Let's say this is equal to 7.8. Moving on, if you have a radical to a decimal, well, what does a radical mean? Again, it's not a survey term, it is a square root symbol. So we're talking about that square root sign. So we have in our normal ideas like this, we have square root, and let's actually do square root of 54. So how do we do this? Well, all you have to do is find the square root of the number and be sure to include about two decimal places. This makes it easier for us to evaluate and compare those other values. So again, if I take and say, all right, take that Desmos calculator, I'm going to type in the square root symbol, and I'm going to say of 54, and let's say, again, I only need those first two decimal points, so I'm going to say it's about 7.34. So I'm going to say, all right, I'm going to use that approximation symbol. Again, it doesn't have to be exact because we're just comparing, so it has to be 7.34. And again, we put those dots to say that it keeps going. So, quick recap, again, it has that, since it does not end and it does not repeat, it is irrational. And lastly, our other form that we have, or other possible form, is scientific notation. So if you think back to previous ideas, make sure you're seeing this. So let's write it first. So let me write what we have. So if we had, let me write down here, let's say if we had 1.32, and let's say, again, scientific notation kind of looks like this. We have times, let's draw that a little bit better, times, one more time, third time's a charm, 10 to the, let's say, to the third, -3 power. How do we do this? So we have to circle the exponent, so let's follow the directions that says. Let's circle that exponent, and now if we're looking at that exponent, it says draw the direction that it is showing. So it's left for negative or right for positive. Well, since -3 is a negative value, we're going to move that decimal place to the left 3 times. So all I'm going to do is I'm going to take that decimal just like it says, and I have that's moving 1, 2, 3 places, and that is going to be our new decimal place. Make sure you include those zeros. I should have 3 zeros there. And so now my value is this. I'm going to say my new value, which I will write, let's say in orange, is going to be 0.00132. Again, just be very careful as you're moving those decimals for yourself. If you'd like to do it using the Desmos calculator, again, be careful as well. So we're going to say exactly like it says. It said 1.3, and we had times 10. Make sure you do the exponent button, which is going to be that A to the B button. That is going to be right here. We're going to hit that, and notice you'll see the cursor or that little blinking line go up, and we have to say -3. Don't forget to include that last value, and so now we have exactly our answer. So again, both ways work. Make sure you're using at least one of them that you know is correct. So now, moving on. It says the strategy that we use for this, the whole reason why we are converting the decimal form is to use that grid to line up our place value columns, and that way we can order our decimals. So usually I'm going to have it set up like this. Again, I have this nice little table. It says, your original form, you have your decimal form, and then you have your order in an original form. And so we're going to use this kind of table for ourselves, so that way we can set up our answers and be able to convert this simply. So now let's take those 5 values that we had in original form, and let's go ahead and convert those back to decimal. Again, we already have those values, so if you need to pause and just write those values down, please do. However, make sure you follow that sweet shank style. Put those decimal points down in the line first. So in the center here where it says decimal form, I want to make sure I have those decimal places already in, because if I don't, they're going to get messed up. So I need to make sure that, hey, I have these values. So let's go ahead and have a decimal place, another one, 2, 3, and 4. As long as those are all in a line, I know that for sure that is going to be the correct columns, because if those columns are messed up at all, then this is completely pointless and you wasted not only your time but also mine. So make sure you're lining those up carefully. So again, using those values that we had, we said that 3.5 was 1.5. For 4 1/5, we said that was 4.2. Again, make sure you only use 1 digit per box, that way it keeps it nice and clean. Again, it might be a little bit more difficult for those people with handwriting. Again, this helps you kind of box in that handwriting for yourself, that way it doesn't get too crazy. So 7.8, we said 7.34, and that last one, it was 0.00132. So now this is how we set it up. So okay, we change it to decimal form. What are we going to do now? Well, we're going to use this. You can use your hand, you can use a column for yourself, a piece of paper, however you want to do it, whatever works. I usually use a ruler or a piece of paper in my hand, and what you do is you want to compare these values. So notice how I'm covering up these columns, so that way it's a little bit easier to follow. So what I'm going to do is, let's say if we want to put it in order from in original form, let's do for this one, let me actually put it there. Let's say if we're doing least to greatest, which of these values is the least? Well, there's a lot of numbers going on here, but if we actually cover up these values, which one is the smallest? Well, it becomes a lot easier because all you're having to do is compare. I have a 1, I have a 4, a 7, a 7, and a 0. Well, out of those values, which one is the least? You guessed it, it's 0. And so what I'm going to do is this, I'm going to write in original form that value, and so I said that the scientific notation is going to be our smallest. So we have 1.32 times 10 to the negative 3 power. And what you want to make sure you do is you want to make sure that you go ahead and cross that out. That way you know you used it. Alright, so now same idea, cover up these values. You want to say, okay, I already used that 0 down there. Of the ones remaining, which one is the least? Well, if you look, again, we're just comparing the 1, the 4, the 7, the 7. The 1 is the least, and so we know that is going to be our smallest value. So we would say, okay, in original form, I have 3/2 as our smallest or next largest value. Cross it out, make sure that you used it already. So now, of the ones remaining, which one is the smallest? It's going to be the one with a 4 in it. And so we say, alright, in original form we have 4 1/5. Cross it out, and now, okay, here's the tricky part. Well, you might say, hey, Mr. Shank, I have 2 7s here. Those are equal values, and I would say you are correct. However, the reason why we do this is now you can shift this to the right, and we're going to move it past that decimal place, and we're going to say, hey, now that you're looking at these decimal values, which ones are the smallest? So I'd say, okay, well, the 7.3 is smaller than the 7.8, and so that's the one I'm going to write down next. And so I'd say, okay, I have my square root of 54, cross it out, And then lastly, but not leastly, my value in order is going to be 780%. So again, for this order, it's going to have 780% as the greatest value. Again, this is a lot to take in, so make sure that you do see it carefully, and be sure to super slam that subscribe button.